Okay, Bill, it's Mikey. I'm going to try to explain this to you. So, I think we're going to start here. I'm going to tell you what we need, and then I'm going to explain how they're connected. So, you need a 1 amp fuse or circuit breaker, something real low amperage, and then something rated. So, if you're doing 110 volts at your house, that's 20 amps. So, get a 20 amp rated fuse or circuit breaker, DIN mounted for both those. Then you also want an off switch that has a normally closed contact. So these are momentary on and off buttons, spring loaded. And then you want to make sure that the off switch is normally closed. I like the 22 millimeter diameter ones. You can get them at Factory Mation. WEG makes really nice ones, or you can get the ones from China, and they're real cheap. And then you need an on switch, and you want it to be a normally open contact. So sometimes when you buy switches, if you buy them from WEG or somebody like that, you buy the button, and then you buy the contacts that you connect to the button. So for your off switch, you're going to have normally closed, and for on switch, it's going to be normally open. And like I said, those are momentary, not latched. Then you said you already had a 24 volt power supply. I went with 24 volt only because that's fairly common in contactors to get a coil. So that's the next item on here is a contactor with a 24 volt coil rated for the full load amperage of all the devices you're going to connect to it at 110 volts. So that means look up your KBAG or whatever that is, KBAG, and then whatever your motors are, and figure out the total amperage that it's all going to consume at 110 volts AC. And then you'll buy that contactor. So they're usually sold in like series. So maybe you'll buy like a series 22 contactor. And what it'll have a rating on what it's rated at. Typically, most contactors, that's what this box is here. They usually have 3 connectors because almost every contactor is built for 3-phase. But in our case, we're only going to use 1. But my point is that they rate them typically at 230 volt or 460 volt 3-phase. And so you need to make sure you're looking at the single phase rating. And if they don't have that, then it's a matter of just dividing in half. So let's say this was 50 amp rated at 460 volts 3-phase. If it was rated at 230 volts 3-phase, it would be 25 amps. Okay? Now, if it was that, but then you want the single phase rating, you divide in half again. So in this case, it would be 25 volts 3-phase at 230 volts, or 230 volts single phase would be rated at half of that, which would now put us at 12.5. And then if you're going to rate that at 110 volts, you divide in half again. So now you're at like 6 amps. Even though it's originally rated 50, you need to do the math and make sure that it's capable for 110 volts going through it, rated for the amperage you want to run through. Now, on a contactor, you usually have 3 main screws right there, 1, 2, 3, and those get connected when the coil, that's what these 2 little buttons here at the top are, when the coil is connected to its control voltage. In our case, we're going to use a 24 volt DC control voltage. So you want to make sure that the contactor is rated for, its coil is rated for 24 volts DC. Now, you'll also know I've got a little box out here. Almost every contactor has at least 1 and sometimes 2 normally open contacts on it. And that's important as when we get to the control. So let's go up to the top now. The lines coming in here are from the wall, okay? So from the wall, 110 volts, you have a hot, which is your black wire, and then you've got a neutral wire and a ground, okay? So ground in your box, you're going to run to the lug that grounds pretty much everything that gets connected inside there, right? And what I do is I connect that back plane, that steel back in my box to ground. And then when the DIN rail is screwed to that steel back, now the DIN rail itself is grounded. And then you can buy green DIN terminals that when you bolt them down, when you screw them down to the DIN rail, then those contacts themselves are grounded. And that's why I've drawn the ground symbol here and here, because you can put one of those blocks wherever you want it. If you look at the pictures of like my controllers, you'll see those blocks throughout the box, okay? Now, this is a 20 amp fuse. Ignore this line, I drew it by mistake. Just remember, we're not going to talk about that. But this is the 20 amp fuse block. Okay, I put fuse, you can buy circuit breaker. Those are probably newer, they might be more expensive, I don't know. But you want to run the power from the wall through that circuit breaker or that fuse, okay? And then you're going to run it to two places. You're going to connect it to the AC hot input on the 24 volt power supply, right? That's going to say line. And then you're also going to connect it to one of the main lugs, not the coil, but one of the three main lugs, what I call the high voltage side of your contactor, okay? So what that does is that brings hot AC power into the top, but it's not connected. Until this contactor itself, there's a middle section, until we supply voltage to the coil, when that happens, the center section sucks in. It makes a clunking sound. And then these lines here, these three, get connected. And that supplies the hot voltage out. Okay? So, what we have to do is we have to build a control voltage to control when power is applied to this coil. So when we apply power to the coil, we know it's going to turn this on. And then this is going to come out. And this is going to go to all devices that are 110 volt. I'm writing here. Hopefully you can see this. Okay. But this is the main part. This 24 volt power supply, once we've supplied power into it from the top, and we've also got the neutral running here, and then neutral going in. You do not switch neutral. Never switch neutral in anything you design for 110 volts. Okay? That's why that line's just going all the way down to the devices here. It doesn't go anywhere. Okay? But you have to supply voltage to this power supply. And so what that'll do is I asked you earlier if you had a disconnect. A disconnect would disconnect right here. It would disconnect the power coming into the box. If you're going to get one, it goes right here at the very beginning. Okay? That disconnect, when it's on, is supplying voltage to this 24 volt power supply. So anytime the disconnect's on, this 24 volts is on. Now that's fine because it's DC and it's low amperage and it's not going to hurt you. And that's what you want your fingers to touch. You never want your fingers to touch buttons that have high voltages. I never design anything I build with 110 or 220 volts running through switches. You can, it's just not safe. That's why all industrial electronics always has 24 volts AC or 24 volts DC as the control voltage. Okay? Because if you get shocked, it's not going to kill you. Right? So, we now have power here to the 24 volt power supply. Now we've got the common. This is 24 volt common and 24 volt positive. Okay? We're going to take that 24 volt positive. I drew it in red. And the first thing you do is you're going to run it through that 1 amp fuse. Okay? So, if something were to happen, let's say you were to short out and short yourself, that 1 amp fuse is a quick blow. It's going to go right away. That's what makes it safe. Okay? Then you're going to run out of that 1 amp fuse, you're going to run it through your E-stop, okay? And your E-stop, down here on the bottom, is a normally closed contact, okay? That's why you'll see me say NC. Anytime you see NC, that means normally closed. So it's normally closed, so that means power is going to freely flow through it until you hit this button. And when you hit that button and plunge it, power's disconnected from there, okay? But this is not the off button. This is a true E-stop. All right, you can put this wherever you want. You put it on top of your box or put it over by your controls. But when you slam that, it's going to kill the power to everything that's powered by 110 volts. Okay, so it comes out of that normally closed E-stop, and it's going to go over here through the off button. And the off button, make sure I see this, is normally closed. That's NC. Okay, and that's what this symbol is. 2 circles with the line touching it. Right. And so what this means is the 24 volts is going through the off button all the time, right? Until you press the off button, at which point the spring opens in this. That's why I say it's normally closed. When you press it, it becomes open. Power is always going through it. And it's going here to the on button, one side, okay? One side of the on button. The on button is normally open. That's why the line's drawn at the top, right? And so when it comes, it goes here, but it also goes from where it connects. It also goes to an open spot over here on the contactor that's normally open, okay? So that means power, well, as long as it's plugged in and the disconnect's on, is always going all the way through here, but it stops because it's normally open here and it's normally open here. Okay? Now, the other half of the control is wired to the other side of the open. It's wired here, and it's wired to the other side of the normally open. Okay? And then it's wired to this connection on the coil right here. So, then we see that the common comes out and goes through here. Now, sidebar, if you're going to install a overload relay, which is also potentially a potential purchase with the contactor, this connection would go right here, right? But they get bolted to the bottom, okay? And so the point all that's doing is on that overload relay, there is a when it's not at amperage, it stays closed. But if it goes above a certain amperage, it opens. Or temperature, I think, is the thermal relay. Don't worry about that right now. Let's just worry about the contactor. So, anyways, remember, voltage is going all the way through until we hit the button. When we hit this on button, we connect it. And what happens is power then flows through this line, through the switch, okay, through the switch here, and it goes all the way up, and it touches this coil. And when that happens, the coil becomes energized, and power is supplied from the coil through this contactor, and it sucks it in. And when that happens, this normally open right here becomes normally closed, okay? So now, even though we let off of this momentary button, because this is normally open, but power sucked it in, it stays. It's called magnetically latched. This is where the magic happens in the contactor. Okay? That stays powered and will stay sucked in until we break the circuit. Okay? And the reason for that is power is now going all the way through and going through here up to the coil, and it stays latched, right? So that's now it's on. When that happens, 110 volts is going through the contactor and supplying all of your devices. Everything down here. So, how does it turn off? Well, when we hit this button here, the off button, now it opens. Okay? Now there's no longer power applied here, right? If there's no power here, that means there's no power going over to this normally open section. Okay? It's not going through, or actually it is going through, but when there's no power going through, this is closed because it's on, it's no longer going to the coil because we broke it there. We broke it over here. So now this power goes away. There's nothing latching that coil. This then opens. It goes back to its normally open state. So then, even though we let off the off button and power comes back through there, this is no longer closed. And that's why the power doesn't suck it back in here. That's how a contactor works. And that's why this is how you wire it up, right? So our safety is the 1 amp fuse here, the normally closed e-stop, which we can smash at any time and open it. And then we also have the off button. So hopefully I've explained this well enough to you. Watch this video again. I talk kind of fast. Ask me questions, whatever, and we'll get you solved. But here again, these are your purchases for 24 volt controls. Now, if you decide you want to do 5 volts or 12 volts, if you can find a contactor rated for what you need it to be, whatever the amperage is, and again, it's 110 volts, so it's probably going to be, it just needs to be 20 amps or less, I'm guessing, right? 20 amps, 110 volts, AC. That's the rating on your contactor. But you can buy them huge. I mean, you can drive 100, 200 amp type stuff with contactors. And doing something this small is fairly easy. But anyways, there's your purchase list. Send me any messages. Hopefully this video will help you. We'll talk to you later, my friend.